Today we're going to take a look at section 6.3, simplifying complex fractions. Let's start with the basics. If we take a look at 1/2 divided by 3/4, think about what you would do first. Also think about what is another way you could rewrite this. To solve this, you could take the second fraction and take the reciprocal and multiply with it. Another way to rewrite this is to show it as a fraction upon another fraction. And this is how we're going to kind of look at these using polynomials and various variables throughout different examples. Example number 1, we have two fractions within each. All four parts, both numerators, both denominators, are monomials. So there's really no factoring, no simplifying in that sense. What we are going to do is we are going to rewrite it so it's kind of expanded so we can see how it's canceled. What we're going to do is we're going to take the 9a squared divided by 5b, and we're going to then just flip it around and multiply with it. From there, you can start canceling and reducing. So the 3 and the 9 reduce to 1/3. This b will cancel and finally this 5 and 25 will reduce to 1/5. Then you're just going to simply multiply across. And you're left with 1/15 AB. We're going to do the same thing with example 2. We have 6x over x minus 5 divided by 12 over x plus 5. So what we're going to do is we're going to multiply by the reciprocal. Once we do this, we're going to see if anything cancels. Now, you'll notice that we have a binomial in the first denominator and the second numerator. So those won't cancel out. But the 6 and the 12 do reduce. So we'll cancel those out. So it's 1/2. And we're left with x times quantity x plus 5 over 2 times quantity x minus 2. I'm fine with you guys leaving it in factored format. You do not need to distribute the x or the 2, so this will be our final answer. Example number 3 is a little bit more complicated. You'll notice that there are binomials in both the numerator and the denominator with multiple fractions in them. We're going to start by multiplying by the reciprocal. But if you look at the denominator, it's not a monomial, so to do the reciprocal, we can't really do that quite yet. We need a common denominator in order to take the true reciprocal. So let's start by just making it an expanded form so we can get a better idea of what it looks like. Since these are two different binomials, what we're going to do is we're going to get a common denominator in the first process. Common denominator would be y squared. So what we're going to do is we're going to multiply 1 over y by y over y. What that does is that makes this a common denominator. And then we can make it into kind of a monomial, bringing together the x and the y. We're going to do the same thing with the second part. The common denominator is x squared, so we need to multiply by x to the second fraction. What that will do is we'll also make it a common denominator, so then I can just subtract the numerator. Now I can take the second fraction and flip it and go ahead and reduce. If you look at this, you'll notice that it really doesn't directly cancel out. But hopefully, if you take a look at x minus y and y minus x, they're very similar to each other. What we can do is we can change this y minus x into negative 1 times negative y plus x. What that will allow is it keeps the denominator the same, but allows us to cancel this with this. So our answer is x squared over negative y squared. Example number 4 is very similar, it just has a different formatting. You'll notice that there aren't fractions within the fraction, but you'll notice that all these have negative 1s on them. What the negative 1 represents is an inverse. So what we're going to do is we're going to rewrite it as a fraction. Basically, this x to the negative first means 1 over x. This negative 1 means the inverse of it, so we put it over 1. And since the negative 1 is strictly with the x, not the 2 stays in the numerator. And that applies to the rest of the terms. Now we can do what we did last time by finding common denominators for each of the parts or each of the terms. You don't have to expand it. In your book, they do keep the fractions within the fractions. So if I look at the top, I'll notice that my common denominator is xy. So I'm going to add a y to the first fraction and an x to the second. The same actually happens in the denominator. The common denominator is xy. So I add a y here and a y there. And an x here and an x there. So you end up getting 2x plus 3x over xy divided by the quantity y minus 2x over xy. Now we can take this and multiply by the reciprocal. Now if you take a look at this xy in the denominator cancels with this xy. And hopefully what you notice is that the denominators in this fraction before that are the same. If that happens, if both the denominators are the same and the fractions within each other, you don't have to show that expanded part. You can automatically just cancel them out, and you're left with the fraction 2y plus, there should actually be an x there, 3x over y minus 2x. Now, you should check to make sure that the fractions don't factor, or each term doesn't factor. In this case, it doesn't, so we're going to leave it just the way it is. This brings us to our last example. 5 minus 3x to the negative 1 and 2 plus the quantity 3x raised to the negative first power. Pause the video and see how far you can get. Hopefully what you recall is the negative 1s are inverses. So that's the first thing I'm going to take care of. 5 minus 3 over x divided by 2 plus 1 over 3x. Now I'm going to take a look at them and make each numerator and denominator have the same denominator. So in the numerator, I'm going to multiply by x over x because 5 is really over 1. So the denominator in the numerator is x. And I won't have to do anything to the second fraction. In the denominator, 2 over 1, I look at the common denominator as 3x. So 3x over 3x. And I don't have to do anything with that second fraction. So we're left with 5x From here, we're going to multiply by the reciprocal. And see what we can reduce, which is only this x and this x. And we get 5x minus 3 over 6x plus 1 times quantity 3 in the numerator. There is an alternative way that the book shows you on how you can use the common denominator with throughout the whole fraction to cancel out right away. So if you look up here to the beginning, instead of multiplying just by x, if we multiply for a common denominator 3x, it will kind of change the process a little bit. So I look at all the denominators of the 4, and I find that the LCD is 3x. So instead of multiplying by x, I multiply by 3x here, 3 here, 3x as I did last time, and nothing there. What this allows is we have 15x minus 9 over 3x divided by 6x over 3x plus 1. And just like we talked about before, if your denominators are the same, you can cancel those out, and that's 15x minus 9 over 6x plus 1. While this looks a little bit different than our answer, it's really the same. We just didn't distribute 3.